Hello, this will be a quick example how to classify your set of elements, forces or anything else. In this particular example, this script is developed to classify support piles. So first of all, I have a DVG drawing of different soil zones, for example, first, second, third, fourth zone, and so on. And I also have locations of the piles, x, y, z coordinate, as well as force in this particular coordinate. So I can use Grasshopper script. This particular script should be available to you. So first part, reading Excel, should be self-explanatory. It's simply reading this Excel that I have here and combining it together, sorting the data so that I have two lists. First of all, list of locations, Rhino point coordinates that I can turn on and I can see these coordinates. And I also have list of forces in each of these specific points. Simultaneously, I am reading data from the Rhino model of the soil zones, the boundary edges, as well as the descriptions. These text objects, where they are located, and what is the text they are containing. You should take into account that the order between the boundary lines, the order of these soil zones, and the order of these text objects could be different. So we definitely need to pair them together. So afterwards, first task is sorting piles within which zone which pile is located. Here I simply have one large list of piles, and I have these 10 boundary edges grafted into each separate branch. And what I'm doing is I am basically finding a relationship between cross-referencing each zone with each location and getting a list of what is the relationship. Is it inside the curve, within the curve, is it on curve, or it's outside the curve? And afterwards I'm creating patterns where the true values are if they are within the curve, and generating filtered, afterwards culling and generating filtered patterns. For example, I can check with tree branch, taking a specific branch, and for example, let's look at branch number 5. That if I look at it, it is this particular branch. Description is it is by luck that it is the same number. It's possible that it's by creation or order of creating, that this is simply the 5th text item that I placed here. If I would delete it, copy paste it here, another one, just an example. Yeah, but it will still be the same. Okay. Similarly, I can also check with the same method this soil zone, that it is also this 5th one. So we have sorted all of our 4,000 piles into specific these zones. That I have 10 branches of coordinates, Excel row indexes, and forces filtered. Similarly, I am sorting also these descriptions of these piles to find which description is within which zone. And I'm retrieving the description's location, the bottom left corner, as well as repeating the same process. And in then acquiring a list of these zones descriptions. Afterwards, what I need to do, I want to also classify not only by these piles by zones, but also by force domains. Sort them into similar forces, all of these piles. And in order to do it, I need to multiply this data a lot. So if I go to an Excel, to a more simple example, for example, I could have zone 1, zone 2, zone 3, zone 4, for example, 4 zones. And then currently I have sorted these piles, where each pile could have, for example, 100 piles here, 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 and here. But what I need to do now is divide these 100 piles into separate domains, where I have domain 1, domain 2, domain 3. Let's leave it like this. And in order to do this now, I need to multiply these lists so that I can compare zone 1 with domain 1, zone 1 with domain 2, and zone 1 with domain 3. So that I have lists for each of these cases. And similarly, I need for all of these cases. In my example, I have here 10 zones, and at the very start, I'm generating domains. And I have 4 domains where I want to, by which I want to group these forces, where I want these forces to fall in. And so if I have 4 domains, 10 zones, 10 times 4 means I will have 40 groups. In order so that I could compare and get these lists and filter these groups even more. The method with which I acquire, I parametrically get the amount of domains, how many domains I have here. This length is I have 4 domains, and I am taking each branch that I have here 10 branches, and I am multiplying the values in each branch by this 4. So after duplicating the data, I get, instead of, for example, 600 elements, I get it in each branch 2400 elements. And afterwards, I am partitioning these lists by the same quantity, by this 4. And the end result is that each branch is basically multiplied, but keeping the hierarchical indexes, so that I can know, which branch corresponds to which zone, to which domain, which is basically this first 2 indexes, which is written here. That basically first number corresponds to which zone it is, and the second number corresponds to which domain this particular branch is meant to be paired with. And similarly, I need to generate a list of domains, branches of domains, where I'm retrieving that there are a total of here 10 branches, and I am multiplying my domains by 10, that I had 4 domains. I'm multiplying them by 10, and afterwards splitting them up so that each branch would contain one single domain, but they will be in the correct order. And afterwards, it is possible to check, I'm checking each branch with each branch, and I'm generating a patterns for each of these cases. Are the forces falling in this particular domain or not? So that it's possible to sort them. And afterwards, assigning call pattern, it's possible to group all of these piles also by forces. So now they are grouped by zones and by forces that were in this Excel table. And this, I would say, is the hardest part. And afterwards, generating information that could be copied back in Excel for filtering. As an example, I will copy this in new Excel so that the original Excel doesn't mess up, like this. And here I have these, so here I have these zones generating. For example, I can copy this data about groups. Let's take this one. So for example, groups, copy it in, take these zones, copy data. Let's go back. Oh, this was wrong Excel. So zones, and afterwards also some more complex information, like possibly calculation report could be generated. A much longer string. Let's copy also this. Copy that only, and this will be comment. For example, here. So as a text, that there's a pile number with a specific number with a specific force. It's located at location, which is in zone, specific zone with a calculation ID group like this. And so what I can now do, I can filter them however I want. I can filter a specific zone. For example, so let's select, for example, I will select only a 5th zone, and then in this zone, each zone will consist of 4 groups. I can now select a specific group, and this zone here contains, for example, only forces from 0 to 2000 kilonewtons. I can take the next zone, and it will be this next domain. So like this, for example. And I have these coordinates and so on. And the system is parametric. I can very easily change some of the things. For example, the zones are not numbers. The zones are instead letters, for example. Some zones will be letters, some zones will be numbers. And for example, let's name it good zone, like this, for example. And I can now again copy this data, go back into this Excel, remove all of the filters, and then within the zones copy back this information, copy this data here regarding comments, and groups themselves won't change. And but here I can now get that I change these zones and immediately get them back here in this list that they are not changed. The one and first group, for example, was changed to A and so on, and I can immediately filter them. What I can also do is I can make it different visually in the Rhino itself, where I know the locations of the piles, I know the forces of the piles. I can again simply filter them according to domains, not in these not dividing them in 40 different groups, but dividing them in 4 different groups by domain within which this particular force is included. And here I'm manually generating 4 different colors for the first, second, third, and fourth domain. Whereas this is the lowest force, medium, high, and this is the highest, up to 5,000 kilonewtons. And I am taking these locations, generating circles in each location, transforming them to surfaces, to circles, like this here, and afterwards assigning them. Each domain gets assigned this custom material, like this, where I know it color coded, where there are weak forces, medium, and where are these very high forces. And additionally, I know these locations, I know the forces in each specific location. I can generate a 2D view of them, where in each force I can also see it visually, where the white ones are from 0 to 2000. There won't be any white circle with more than 2000. And the same, for example, the red ones are from 4000 to 5000. And I can see this information easily visually, but if I want to, I can inspect it more closely, like what is the actual specific number from this Excel table in this specific place. And regarding classification, then here's one more simple, very simple method how to find unique strings and how many of these unique strings you have within a list. You can basically ignore this first part. It's basically generating randomized numbers so that I would get 2 lists of random numbers from 0 to 5, each consisting of 5,000 values. And the numbers are completely randomized. But we could imagine that that is a degree of freedom for X and degree of freedom for Y direction, for example. And I will generate a string where I'm combining them together, X and Y. And so that this string looks something like this. There are 5,000 values looking like this, for example. But it can be anything. It can be also like it can be long like a sentence. This each entry. And what I'm finding is that there are 5,000 of these entries in this list. And with a create set function, I can find that there are only 36 unique ones, which is basically there are 6 possible variations of X, 6 possible variations of Y, so 6 times 6 is 36. It finds this 36. And afterwards, using member index function, I can find how many, what is the number of each of these unique connections. For example, this X4, Y5 is 101. To make it easier, I can sort it beforehand. So I'll take these keys and sort them so that it's basically like this. So XO, YO, for example, is in 57 places. XO, Y1 is in 108 places, and so on. And I can easily classify and know what is the amount of some particular connections. Like I can take some kind of beam column connections and classify them by type. Are there joint connections or moment connections, as well as I know how many of connections are in this particular project. And looking at previous example, I can also classify them by their forces, what particular moment and shear forces are in this particular connection. And then, of course, I can also always get this, for example, this XO, YO, in which particular indexes this particular connection is located in. To afterwards locate it, and I also, of course, can afterwards learn what was the location of the seam, what were the main parts, secondary parts, and so on. So I hope this was helpful. See you.